Juan is driving 50 miles per hour. He has already driven 20 miles. Let H represent the number of hours. Let M represent the distance traveled in miles. Create a table that represents the miles traveled in 0, 1, 2, and 3 hours. All right, so remember that we always need, whenever we have a linear relationship, we can write a linear expression, and we can always write linear expressions in the form y equals mx plus b, okay? Where m is called our rate of change. That's our rate of change, and b is our initial value. So this is our initial value, okay, or our starting value, okay, where we start. So that is whenever x is equal to 0. So hopefully you watched the video before this. That would have explained what that kind of means. And let me just write out rate of change, right? Just in case, rate of change. All right. So if we're looking at our word problem, we can see our rate of change is here, miles per hour. Okay, anytime you see that word per, okay, see like miles per hour, cost per minute, blocks walked per week or something like that, or, amount of money spent every month, something like that. That's a rate, right? That's a consistent amount that's increasing or decreasing by the same amount each time. So you spend $5 a day, or you spend $100 a week on gas, or you travel, 100 miles in your car every month, commuting to work, or something like that. That's a rate, okay? So we see that word per. So we know that that's going to be our rate of change. That's going to be our M in our equation. And our B is going to be our initial amount, so the amount that we start with. So it says that he has already traveled or driven 20 miles. So initially, at the start, right, before anything else has happened, he's already traveled or driven 20 miles. So if we insert those numbers into our equation, y equals mx plus b, our m is going to be 50 and our b is going to be 20. So we're going to have the equation y is equal to 50x plus 20. All right, so now it tells us that it wants us to create a table that represents the miles driven in 0, 1, 2, and 3 hours. So let's go ahead and fill in our hours column with those numbers. So let's go 0, 1, 2, and 3. So let's see, and let's just think about that, right? In 0 hours, he's already driven 20 miles, right? It says that. So 20 miles. The other thing we could do is we could, and actually, you know what? I just realized we'll keep the equation the way it is. I really should use h and x as my y and x. As my x and y, but I'll write this. This is going to be my x, our independent variable, and this is going to be equivalent to my y in my equation. So it tells us that he's already driven 20 miles. So after 0 hours, he's still driven 20 miles. So we can find that out from our word problem. The other thing that we can do is we can substitute our x into our equation and solve, right? So we could just do y is equal to 50 times our x here, which is 0, plus 20. So 50 times 0 is 0. Any number times 0 is 0. So we'd have 0 plus 20, which is 20. Okay? That's what we get here. Okay, let's take a look at line number 2, our 1, and let's use substitution for that one too. So let's look here. So let's substitute this x value into our equation. So we'd get y is equal to 50 times 1 plus 20. Well, 50 times 1 is 50, plus 20 is 70. So here we're going to have 70. Let's take a look at our third row. So then we would have y is equal to 50 times 2 plus 20. So remember, you always do multiplication first. So 50 times 2 is 100, plus 20 is 120. So now we have 120. In our last row 3, we would have y is equal to 50 times 3 plus 20, which is 150 plus 20, which is 170. 170. All right, so there's a couple of things that you can glean. So that's how we could fill in an table using our equation. But the other thing is, what if you're just given the table? How could you write your equation? Well, your m would be the difference in how much your y is going up each time, right? We're going up 50, we're going up 50, we're going up 50 each time. Okay, for every 1, plus 1, plus 1, plus 1, right? So our m would be equal to 50 over 1, the change in our y over the change in our x. Okay, how much your y is going up over how much your x is going up or down, right? Because you could have a negative rate too. You could be spending $2 a day, right? So your rate would be negative. And your initial value is going to be the amount when x is equal to 0. Okay, so our initial value, our b, was 20 because when x is 0, y is 20. All right, so 2 different ways that you could approach this. Okay, you could either use a word problem to go to an equation, to go to a table, or you could go from a table to an equation. You can't necessarily go to a word problem, but maybe you could create your own word problem from a table that you're given, knowing how to find the rate of change and knowing how to find or identify the initial value.